calculate stockpile volume and tonnage directly from the point cloud, without the need for DEMs, TINs, or exporting to expensive and complex software. In this video, you'll see how in just 3 simple steps you can obtain not only the volume of your stockpiles, but also their tonnage and a detailed report, and, to wrap up, a verification by comparison with the industry-leading software. The first step will be to create a new project in Visor Cloud. You can create your account completely free and upload your first point clouds. Then, if you see that it fits your company's needs, you can choose one of our plans. Visor Cloud will upload your point cloud file, whether in .las or .los format. It will then be converted for visualization on the platform, and the original file will be deleted, ensuring the privacy and security of your data. The upload time will depend both on your internet connection and on the workload of our servers at the moment you run the processing. However, we've made sure the system provides you with all the process information in real time. Here we've sped up the process, but it's important that you see how the data is displayed in the My Projects panel. Alright, this delay will occur only the first time you upload the point cloud, since that's when it is processed. After that, the next times you or your team access this cloud, it will be displayed instantly. Let's calculate the volume and tonnage of one of these stockpiles. As you may have noticed, Visor Cloud automatically detects the coordinate system and measurement units of the point cloud, ensuring professional-grade accuracy. The first step will be to define a polygon as an area of interest, or AOI. This polygon will define the area where we will perform the calculation and will delimit the optimal fitting polygon against which we will compare to calculate the volume. Once the calculation area is defined, we can now move on to the stockpile calculation tool. We select the polygon we created as the area of interest, and will be asked to define a material from the list in order to obtain a volume and tonnage report. That's it. In just a couple of clicks, we've calculated the volume of this stockpile. We can see the calculation cells displayed as green polygons, which of course we can refine and adjust to meet our specific requirements. Now we can see that the cells shown in green correspond to fill values, while those shown in red correspond to cut values. Let's perform a calculation check by exporting the surfaces and replicating the calculation in Civil 3D. The first step is to export a triangulated mesh. For this, we'll define a perimeter and a cell size. Here, we'll use 1 foot. This mesh will be exported in .xml format, ready to import into Civil 3D as a surface. In the output tray, the export icon appears, and we'll give the file a name to later import it into Civil 3D. To ensure the highest possible accuracy in this verification, we'll also export the bounding polygon of the area of interest, which we'll use to create the base calculation surface. We can see that Visor Cloud returned a fill volume of 305.34 cubic yards. Now, we'll create a new document using the Imperial system. Then we'll import the triangulated mesh we exported from Visor Cloud. We can see that Visor has created a triangulated mesh ready to work with in Civil 3D, without any edits or adjustments needed. It's time for the area of interest polygon. It was exported as a .dxf, and we'll open it. Then, we'll copy and paste it into its original coordinates in the document containing the triangulated surface of the stockpile. Now we'll create a surface in Civil 3D called Base, and include the polygon we exported from Visor Claud as breaklines to define the mesh. This will serve, finally, to create a volumetric surface that will give us the volume data we're looking for. Great! Here we can see that we already have the base surface and the comparison surface we created in Visor Cloud. Now it's time to create the volumetric surface in Civil 3D. To do this, we'll set the base surface as the reference and the stockpile surface we exported from Visor Cloud as the comparison. The verification yields very precise results. In Visor Claud we obtained 305.34 cubic yards of fill, and we can see that the volumetric triangulated mesh in Civil 3D gives a nearly identical value of 305.21 cubic yards. It's worth noting that Visor Claud and Civil 3D calculations don't always match this closely, but generally, we can expect a variation of around 2 to 3%, which is perfectly reasonable for these calculation methods. Now we'll simply save the project so we can return to it later, and generate a detailed PDF report on the stockpile's volume and tonnage based on the material we defined. I hope this tool proves very useful for your stockpile calculations. I also look forward to your feedback. Remember, you can access Visor Claud online, or download the desktop version to use it privately on your own computer or network. Tell us what you think of this tool, and share the video with your colleagues if you believe it will be useful to them.